Discussing about the thermal conductivity. The thermal conductivity is the property of the material to conduct heat through it. We know that some materials are better conductors of heat and some materials are bad conductors of heat. Those good conductors of heat like silver, like iron, like aluminum, like gold, those have got higher values of the thermal conductivity, and the bad conductors or the insulators like glass and wood have got the low value of thermal conductivity. So thermal conductivity is the property of the materials which shows us that the material is either an insulator or a better conductor. High values of thermal conductivity are of the conductors and low value of thermal conductivity are of the insulators. Discuss about the coefficient of the thermal conductivity. Now let us take a slab of this face area and this face area A. The distance between two face areas is delta x. Let the temperature of this face be T plus delta T and the temperature of this face be equal to T. So there is a difference of temperature of delta T. So the heat gets transferred from this face to this face. Let delta Q be the amount of heat transferred. Amount of heat transferred in time delta T. That means rate of heat transfer is equal to delta Q divided by delta T. Now this rate of heat transfer, that is delta Q by delta T, is directly proportional to the area. More is the area, more will be the rate of heat transferred. Less is the area, less will be the rate of heat transferred. This delta Q divided by delta T, that is the rate of heat transfer, is delta T, that is change in the temperature or difference in the temperature. More is the difference in the temperature, more is the amount of heat transferred. Less is the difference in temperature, less is the amount of heat transferred. Now the rate of heat transfer delta Q by delta T is inversely proportional to delta X. That is, more is the distance between the two faces, less is the amount of heat transferred, less is the distance between two faces, more is the amount of heat transferred. Combining these three, we get delta Q divided by delta T is directly proportional to A del T divided by del X. Now this delta T is time, change in time. This delta T is change in temperature. Now eliminating this proportionality constant, we have to introduce a constant of proportionality, and that constant of proportionality is called as coefficient of thermal conductivity. So we have delta Q by delta T is equal to K A delta T divided by delta X. Now if we have to define K, we will take as A is equal to 1 meter square and delta T by delta X equal to 1 Kelvin per meter. This delta T by delta X is defined as the temperature gradient. Now in that case, K is equal to delta Q divided by delta T. So we define coefficient of the thermal conductivity as numerically equal to the rate of heat transferred between unit area and having a unit temperature gradient. That is, K is equal to delta Q divided by delta T. If we have to find the units of K, the units of K will be equal to delta Q, units of delta Q divided by delta T divided by A delta T divided by delta X. As delta Q by delta T, the units of heat are joule per, this is time, that is second, area has got meter square, temperature has got Kelvin, and this distance has got meter. That means it is joule per second is watt. So it is watt, 1 meter square, and this cancels out. So we are left with meter Kelvin. So the units of K are watt per meter per Kelvin. Knowledge of thermal conductivity or the coefficient of the thermal conductivity helps us to select the materials to be used as the better conductors and to be used as the insulators. The high value of coefficient of thermal conductivity tells us the material is a better conductor. The low value of the coefficient of thermal conductivity tells us that the material is not a good conductor or the material is a insulator. Let us discuss about the applications of thermal conductivity. The knowledge of the thermal conductivity helps us in many ways in selecting the materials for handling the hot objects. Likewise, the handles of the cooking utensils are made up of wood. The wood is insulator and we don't get burns while handling those hot utensils. Number two, the new quilts are warmer than the older ones because the new quilts retain a lot of air, which is a thermal insulator than the older ones. So the new quilts are warmer than the older ones. The Eskimos make the houses of ice blocks having two ice walls. In between there is an air gap. That air gap acts as an insulator, and the Eskimos are protected from the severe cold. Number 4, The ice is packed in gunny bags or sawdust because the gunny bags as well as the sawdust has small pores in which the air gets trapped. That air is an insulator and ice melts at a slower rate. These are some applications of the thermal conductivity. So the applications of thermal conductivity help us to choose the materials which are better for the transmission of heat and choose the materials which are not better for the transmission of heat, so that we don't get burned or so that we don't get severe cold. Thank you.